Okay, good. Well, as people continue to filter in from out in the lobby, I just wanted to welcome everyone to this year's showcase. The first thing I want to point out is that I am not Mujdat Chetan, who's sitting right there, and I'm Mark Bacco. I'm the director of CEIS, and Mujdat is the director of the Center of Excellence in Data Science and AI. And so both of us want to welcome you all to today's event. And as you can see, we have a busy agenda in the program. And I just wanted to say a few words before we get started. So it's great to see everyone here at the 2026 Finger Lakes Science and Technology Showcase. And this event, which is hosted by the Center for Emerging and Innovative Sciences, CEIS, and the Center of Excellence in Data Science and Artificial Intelligence, is designed to bring people together from across the Finger Lakes region and throughout New York State to strengthen partnerships, spark new ideas, and accelerate innovation that drives economic growth. Today's program continues that mission. What makes the showcase especially important is that it reflects something distinctive about our region. Rochester and the Finger Lakes have deep and enduring strengths in imaging, optics, sensing, instrumentation, precision engineering, and in the broader interface between technology and human experience. At the same time, we're living through a moment in which AI and data science are transforming nearly every domain of science and technology, medicine, media, and manufacturing. And the opportunity before us now is not simply to add AI to what we already do, but it's to bring these strengths together in ways that create genuinely new capabilities, new companies, new partnerships, and new forms of impact. So that convergence brings tremendous promise. It can enable new approaches to intelligent imaging, advanced sensing, medical technologies, media technologies, human-computer interaction, and decision support. It can help our region build on its historic strengths while positioning New York State to lead in fields that will matter profoundly to the nation's economic future and technological competitiveness. But it also brings important challenges: how to build trustworthy AI systems, how to connect research to real-world deployment, how to prepare the workforce, and how to ensure that innovation serves people well. Those are not abstract questions. They're questions for our companies, our universities, our communities, and our public institutions. So that's why gatherings like this matter. They create the conversations from which collaborations grow. They connect faculty and students with companies and public leaders, and they help us move from excellent individual efforts to shared regional momentum. If we do this well, the benefits will extend far beyond Rochester. They will matter all across New York State, and I believe across the country. So this is the point where I was going to introduce someone who's not here today, unfortunately, but I wanted to introduce and acknowledge Assembly Member Harry Bronson. So I had planned to introduce the Honorable Harry Bronson, who's Assembly Member for New York's 138th District. And Assemblymember Bronson has been a strong advocate for many of the themes at the heart of today's showcase: innovation, economic development, workforce opportunity, advanced manufacturing, biotechnology, and the future of work in an age of AI. He understands that innovation depends not only on new technology, but also on the partnerships, policies, and opportunities that allow it to benefit our communities. So Assemblymember Bronson had hoped to join us today, as he has in the past, but he needed to remain in Albany for the state budget negotiations. But I wanted to acknowledge that we're deeply grateful for his efforts and for the efforts of all of our elected representatives in Albany for their strong support of the Centers of Advanced Technology, of which CEIS is one, and the Centers of Excellence, of which the Center for Data Science and AI is one. So thank you, Assemblymember Bronson, and I'm sorry that you're stuck in Albany. It doesn't sound like a lot of fun. So that's my opening remarks, and I was going to turn this over to Nick Colziol, who's going to be the master of ceremonies for our networking pitches. Okay, thank you.
Thanks, Mark. Good morning, everybody. How are we all doing? Good. How many of you joined us for the Tech Rochester event earlier by show of hands? Ooh, good amount of people. Well, thank you for staying on and for being a part of this special day. I'm not going to stand too much in the way because I'm really excited to hear the pitches from both researchers and businesses in the area. Just a couple little tips and tricks that we've learned in the last couple of years about how this works. So the order of pitches is going to be really quite simple. There's going to be a place marker slide that will indicate that you're coming up. So if you are participating, that's your sign. We are hopefully still going in the order that I gave you in an email. And as far as expectations of timing, I have two lovely assistants down here, and they're going to be holding up a sign that says 2-minute warning, 1-minute warning, and then time's up. So we're trying to move this along as best as we can, because after the networking pitches, we do have 2 awards for our community partners from the COE and from CEIS. But we do want to hear what you have to say and how we can help and impact. And I'm going to take up a little time myself. In your blue zipper binder folders that are really cool and really neat, I really like what Margaret and Kathy picked out this year. There's these 3 different programs that the COE offers. I just wanted to call your attention to it as a company member, nonprofit, or even internally for U of R or RET, we can help you at the Center of Excellence. So we have 3 main programs. I'll go over real quick. Capstone Partnership is a group of students that's in their culminating course. They need data to work with. So over the course of the semester, they'll answer a data challenge from your company or organization, and the team will work together using the latest and greatest technology that they've learned in our programs and work with a faculty advisor on solving that data challenge. We have a research collaboration for a New York-based company or organization that was working with a New York-based researcher. It does not have to be at University of Rochester. We would love if it was, but it doesn't have to be. Any New York-based researcher can apply for that, and actually we have an open call currently closing at May 15th for that. Basically, you get up to $70,000 that goes to the researcher that's partnering with a company in industry over data science advancement and research. And then we have the summer internship program, which we're in the middle of delegating right now. We have 10 positions that we're funding this year, but every year we fund a 2-month experience for a U of R student to work at a company in New York of 100 people or less on data science internships. So these are all our experiences through the COE, and if you have any questions about that, feel free to reach out to me. And then without further ado, we're going to start with the pitches. So Dr. Marcus. Oh, one other thing I wanted to mention, we do have a slide advancer and de-advancer, that's not a real word, with a laser marker that you guys can pass along.
Good morning, everyone. Thank you so much for the opportunity to present here. I'm Susana Marcos. I'm the director of the Center for Visual Science. And my pitch is to actually, familiarize yourselves with a little bit with what we do in the center. We are an interdepartmental program with 9 different departments, mostly from the University of Rochester, but also RIT. We also have young members from industry, and we cover probably the broadest vision compared to any program nationwide. So the center covers vision, perception, cognition and action, visual development, learning and plasticity, multisensory and sensory motor integration. We develop advanced optical technologies for vision, and also develop new treatments for disorders of vision. And that gives a global impact. It really bridges vision science and its applications. CVS is really a hub for academic research and innovation excellence. You have some numbers there, a big number of patents and industry agreements, and also research of excellence. So these are our strategic pillars. I would like you to focus not only on the research of excellence and our programs in visibility and community and training, but also on our technology-oriented programs and new funding mechanisms, many of those in connection with industry. For the last couple of years, we have opened this Industrial Associates Vision Add-on program that is a satellite program to the Optics Industrial Associates. We have now the major companies in the ophthalmic space that have joined us, and that keeps increasing. There's several areas of potential for translation in CVS that relates to AR and displays, multi-sensory integration, visual modeling, eye tracking, but also several techniques to really diagnose and improve vision. Many of those technologies have actually gone from labs in CVS to the real world. These are some of the technologies and companies that were born out of research developed in CVS. And many of those are actually, impacting millions of patients worldwide today. That includes diagnostic technologies in vision, as well as new treatments like new intraocular lenses. So really, Rochester Vision Innovation Ecosystem is thriving. I just mentioned a few of the programs that really contribute to this ecosystem, and we're glad that the Center of Vision Science is in many ways at the center of it. I thank you so much for your attention.
Thank you, Susanna. My name is Paul Valentine. I'm a Deputy Director of CEIS, reporting to Mark Bacco. And I'd like to give you an quick overview of what CEIS is. Many of you already know that, but a few of you don't, so I'll just kind of briefly review that. So NISTAR, or CEIS, is a Center for Advanced Technology, part of NISTAR, so the same part of the New York State government that funds the Center of Excellence. We're two very similar ones, but we're funded under separate statutes, so we act a little bit differently. The same as the Center of Excellence, the purpose is to drive economic development through industry-university collaboration. We're funded to the tune of about $1 million a year, and recently, last year, we were awarded a 10-year renewal of our contract, so fantastic news, and we'll continue to be able to do what we're doing for a while. So we work in two different ways. One is we provide matching funds, similar to what the COE does, but that's a mainstay of what we do, and a company match is required, and I'll talk about that in a second. And then the other thing we do is do some strategic initiatives, and I'll talk with one of them later. Now, the interesting thing about us is, although we're based at the University of Rochester, we fund faculty and university collaborations, both at the U of R and RIT, which makes us somewhat unique, but there's a whole lot of industry-university collaborations going on with faculty at RIT, so they're an important part of that. Mostly we work with Rochester area companies, but we can really work with any New York State company. The NISTAR really covers this full state, of course. And we've funded many startups, spin-outs of the university and other small companies that get launched by licensing technology from the University of Rochester or RIT. And so that's part of that. I only got 1 minute left. So we have two funding opportunities, a larger one which requires a 2-to-1 match on the part of the company, and a shorter term applied research, which is smaller companies, and it only requires a 1-to-1 match. Now the last thing I want to talk about is one of these strategic programs that we're involved in, which leverages the imaging technology in Rochester with the tsunami wave of artificial intelligence, and we call it intelligent imaging. And if you think about it, any image you capture now that is being digitized, artificial intelligence can help discern what's in that image. But also, artificial images are being created by AI, and that really poses a serious problem to individuals, but to the whole country in terms of, you see what's happening in the Iran war of fake images. So our objective is to establish a national center eventually, and there's opportunities in federal funding to the tune of up to $20 to $50 million a year, so very significant. this is a once-in-a-generation opportunity for the industry, for the region. Thank you.
Hello, I'm Atma Anand. I'm a graduate student in the Physics and Astronomy department. I've been working on plasma astrophysics for the last few years, but now I'm also going towards thermodynamic computation. And here I'm trying to look for collaborators who do distributed computing or neuroformic computing or thermodynamic computing. The basic idea is that applying evolutionary biology techniques, finding the physics in that, and trying to do machine learning with that. To go to the code by Lewis Carroll's Red Queen, or the Red Queen dynamics and evolutionary theory, you have to keep running to stay in the same place because everything around you keeps evolving. So I'm taking this approach in the toy model, which uses Kuramoto oscillators and Kalman filters, and I have a poster about it, which you can look at in the later half of the day. So this, the framework that I am deriving, it combines statistical mechanics, topological impossibility theorems, and emergent complexity. The main result is that the information needed to coordinate multiple agents scales non-linearly. And because of that, the communication cost outruns any information processing cost itself. And once you have disconnected domain, which you will have due to multiple reinforcement learning components, the gradient descent cannot cross topological boundaries, so you literally have to jump across it, and that leads to what we call singular perturbation in physics. And finite resources is what constrains everything. So if you want to know more about all of this, come to my poster. Thank you.
Hello, my name is Michael Bernkrant. I'm with a startup called Freehold ASO, and we focus on building up a couple different startups, but I'll talk about one today specifically. The idea here is that you have these disconnected pieces of the insurance industry, and where this appraise product actually focuses on is a problem that comes from when you have a accident, you actually go through the process of getting an appraisal, and somebody comes out, will inspect the car, and assign a value to it. And then the insurance company awards that value to the owner. And if the owner doesn't like that value, then they go through the process of arbitration, which in New York State, there's a whole set of rules that are set up to create a pathway that eventually leads to litigation, but before you get there, there's an arbitration. So now, what we are focused on is really solving that problem with AI and going through the process of stripping out all the parts that are non-value added, focus on the negotiation, and put guardrails up to really help the negotiator work to ascertain the correct value of that asset. And in so doing, they create a large amount of data that is useful for the insurance company as well as substantiation of the appraised value. And so with that, you actually create a very fast efficiency in a very highly litigious environment. So what we're doing is building up that guardrails for the AI to really drive at some of the key things that are causing problems in this area, which eventually leads to the value being set at the right level for the asset. And so what we're doing is taking the data from different areas. You can see it up here from the customers, from parts, repairs, shop analytics, and regional insights, and then driving that through our system. At the end of the day, we're getting to the point where we have the better controls on the whole process and are able to substantiate that both in the negotiations as well as in the courtroom. And so we're 6 months in, we're doing well, we're getting some traction, and looking for partners in this area. Really appreciate it. And our contact information is up here. Contact Ron Chirozzo, autoappraisals@appraisalflow.com. I really appreciate the time and look forward to talking to you.
Hello, I am Damon Deal of NextCore, and I am excited to talk to you today about the Luminate Startup Accelerator, which is one of the programs of NextCore, and I'm the Director of Technology Integration with Luminate. Luminate is the only startup accelerator in the world that is exclusively for startup companies that have optics, photonics, and imaging as the underlying technology. It could not exist anywhere other than Rochester, New York. And we are both an accelerator and an investment fund. We are funded by Empire State Development, and we are able to invest $3 million in these startups each year, in addition to focusing on them being investable at the end of the program. We have had 85 companies go through the program so far. We just added another 10 this year. They came into Rochester last week. The estimated value of the Luminate portfolio has reached $700 million, and one of the magic things about the program is that for every dollar that New York has invested in these companies, they have been able to raise $17 on their own. We are agnostic to market. We only care about the underlying technology. So as you can see here, these are the sorts of entrepreneur companies that we look for in our program. So all of these are representative of companies that have gone through the Luminate program. And the way that we are structured is that we bring 10 companies to the program each year. There were 130 applicants from around the world. We give them $100,000 of investment at the beginning of the program, and that enables them to spend half of that in Rochester, New York. And that is part of why I'm here, to learn potential partners for them. Through the course of being in Luminate, they have access to all of the resources that you guys have here in New York. We provide 150 hours of content training. That is now the reason that people apply to Luminate. They do not apply for the investment, they apply for that training, which is what makes them investable at the end of the program, which is behind that 17-to-1 investment ratio. And at the end, when we invest this other $2 million, $1 million, that's based on our appraisal of the value of the companies. And thank you very much.
Nice to be here. I'm Chen Ding. I'm professor and chair of computer science at the UFR, so I'd actually be happy to talk to people here about work at the department as well, especially AI, not so much applications, but fundamentals. But for my purpose, the slides, I want to tell you about prototyping and intellectual property development for a RISC-V processors with a programmable cache. So open source software started at the end of last century. Now you see it's just its dominance. Linux runs almost all the computers in the cloud, including Microsoft Azure. Now, 10 years after open source software, RISC-V started the open instruction set architecture for CPU processors. And now we're seeing broad adoption. I'm listing the market segments from automobile to consumer electronics. I should definitely have put optics there. If you think about the processor projecting right now, there is a processor. The benefits of open source, same as software, similar in hardware, there's no licensing fees. You can customize, you can add instructions to the processor. And the security and ecosystem is really through the open standard. That's part of the reason why Microsoft has to support open source to play in the field. And then now we have AI tools, so we have new productivity. So my work for the last 3 decades is locality theory and optimization. You see some of the national awards. I actually received the first round of Department of Energy Young Investigator Award, and 5 years later, my student probably was the first recipient, legacy recipient of the award. And then descendants of this line has now faculty members to many R1 universities, including Penn, Rice, and the UCSD. But in the last 5 years, I've been working with Professor Petru to have programmable cache through partly NSF funding. Now we have prototypes on multiple FPGA boards, and the technology is maturing. So this is really the message I want to bring. The current caches are general purpose, not programmable. The work by NVIDIA, will show, on the right, it's the adding limited programmability. So with moderate investment, we can develop a prototype showing general programmability on CPUs, and then acquire patent protection on both CPUs and the GPUs. So the prototype may be a product itself, and then the IPs and designs could be licensed to hardware vendors. So finally, I want to show that plot from an NVIDIA paper, this rapid increase in the last level cache on modern AI processors. So the cache is a significant, if not a majority portion of the chip real estate. They are as much a processor chip as a cache chips. NVIDIA, $4 trillion market cap of Google. But my statement here is not how much these companies make from these chips, but how they make that much money. Thank you.
Good morning. Almost every breakthrough in this room, it's my job to click. Almost every breakthrough in this room in optics, photonics, imaging, sensors, medical devices, or AI will eventually be experienced through someone in the lens of the software they use. And that interface is the difference between an interesting prototype and a funded product. I'm Paul Gable from ITX, and building that software layer is what we do. ITX was founded in Rochester in 1997, and we've got about 270 professionals across the globe, mostly in the US and LATAM. We're a product development partner. We have deep roots in UX research, product strategy, engineering, cloud security, data science, and ongoing maintenance and support. We work best with engineering-led organizations who are mid-market modernizers, deep tech founders, university spinouts translating IP into revenue. I wanted to tell you a brief story about a client that we worked with that'll give you a better picture about what ITX does. We worked with a venture-backable medical device producer. It was a hardware-centered team. They were strong in clinical science, and investors wanted to see how a clinician would actually use it before they wrote a Series A check. No internal software UX capacity in the organization, and a full build would simply take too long and needed too much pre-funding. ITX came in, we did discovery in weeks instead of months. We developed high-fidelity, clickable prototypes that were non-disposable, became the foundation for the ultimate software layer that ended up in the build. But we were able to pressure test it, walk it through actual clinical workflows, and actually give investors a mock-up that was more than just pixels on a screen that showed a scalable, secure, enterprise-grade software experience. The prototype helped our client close a Series A from a Tier 1 VC. What that lesson means is that the deep tech teams that are building thoughtful, interesting, insightful, groundbreaking science, like those represented in this room, often have challenges getting that technology to market. That's where we show up. If you're commercializing research and staring at the software layer wondering who should build it, I'd love 20 minutes of your time. The best way to get in touch with me is through itx.com and just submit a web form there and tell them that I sent you. If you're already shipping software and your team is maxed out, we embed vertical slices or full teams in product, UX, AI, data engineering, and our capacity behaves just like your own in-house teams. If you're running an accelerator or you know a founder in that spot, whether it be NextCore, Illuminate, CEIS, We'd love introductions would be the best gift for our work in the community today. Again, my name is Paul Gable, and ITX turns hard science into software that people actually use. Come find me. I'd love to hear what you're talking about more than what I do. Have a great rest of your day.
Hi, everybody. I am Carla George, and I'm here representing FLX AI today. FLX AI is an AI advisory and execution services firm based here in Rochester, New York. We've been together as a company since 2021 when we spun out of the University of Rochester. So a little bit of history, we were actually formed under the university in 2017, so almost a decade ago, which is super hard to believe. But we came together as a group of business professionals, applied data scientists to serve the region's businesses and help them leverage their data for economic impact. We had a tremendous amount of support when we were at U of R. We took advantage of all of the programs that Nick talked about and partnered with our friends at CEIS. And because of all the work that we put in at U of R, we were able to spin out with U of R's support. Today, our services have grown. They're a bit more robust than they were 10 years ago, but we are mainly brought in to help businesses build precision solutions that solve a specific problem. So our customers historically have come to us saying, hey, we've got this gobs of data, we've got this problem, and we sense we have a hunch that AI could probably help us do whatever we're doing faster and better. So we come in and we build that solution, and we use other friends that we've heard in this room to help bring that software to life. Today, as the world is evolving and we've just been hit with this wave of generative AI through large language models, the profile of who's coming to us for help is changing. So where in the past we've had very specific questions come our way, now our customers are saying, we weren't really sure about AI a few years ago, or maybe a late adopter, but today we know that we need to integrate AI into our systems, but we're just not sure where to start. So with these customers, we help bring them on a journey, figure out where they could be investing in AI in a low-risk way. We work across domains, across data modalities, but I will say on account of who our early partners were, we have significant experience working in highly regulated industries. I'm going to skip this on account of time. If you want to talk specific use cases, feel free to grab me after this. What makes FLX AI different? A lot of times we're asked, who's our competition in town? And we struggle to find a firm that's exactly like us with the deep technical experience that we have in a very accessible leadership team on the technical and the business side. Oftentimes when you use a consulting house, you're sold by a senior partner and you have a first year doing execution. At FLX, the majority of our team is 20 years post-graduation and a lot of great experience. So if you're interested in having some AI support, come find me after this chat. Thanks so much.
Good morning, everyone. My name is Haolin. I'm currently a third-year PhD student in the Institute of Optics, and my thesis project is to investigate if we can use polarized light to identify nerves in real surgical settings. So the problem we are targeting at is actually really straightforward, but unfortunately very common. So as you can see in this illustrator image, the nerve is buried in different kind of tissues. And in this example, it's a carpal tunnel release surgery. The surgeon actually need to cut loose a lot of tissues to release the compression on the nerve. And if the nerve is not identified in this procedure, accidental nerve damage could happen, and that's not good for all of us. So it would be nice if we could have some visualization aid to highlight the nerve in some way and tell the operator, oh, there could be a dangerous nerve, don't cut it, things like that. We would love to have it. And when we are talking about a visualization aid, we wouldn't want a bulky system like a microscope. We want something that's portable or even wearable during the procedure so the surgeon could just use it right away. So as a optics people, we think using simple optics and advanced data processing would be the way to go to get a non-invasive and real-time system to do the job. So our configuration, we call it the rotating cross-polarization system. which consists of 2 linear polarizers and a motor to rotate everything. So different tissue, what this system does is just record how different tissue is modifying the polarization state of the light. So in this example, you can see different kind of tissue are giving different response in intensity as the polarizers are rotating. If we plot that data out in time domain, you will notice that the nerve is giving you a perfect sinusoidal profile there. And if we apply our processing technique on it, we can get an output map that highlight the nerve pretty nicely. And all those results are started by doing animal models, and they are published in this paper last year. And we've also been taking this system into real surgical rooms. I'm sorry about the scary image on the left. Believe me, it's always shocking to me, an optics student, when I find out how amazing it is in human body. But after processing in real time, we can actually highlight the nerve pretty good, as the green arrow shows. And in the first stage, 30 patients, we got a AUC of 96%, which is really good. And to improve the segmentation result, we also trained our first model on a pretty limited data set, but that's good, the model converged. So the next step of our project would be expanding the data set and finding more advanced classification models. And this research is funded by COE. I would also like to thank Dr. Milton for taking care of me in the surgical room, and my advisor, Professor Knox. And please stop by our poster. We've brought a live demo. Thank you.
How's it going? I'm Mike Heilman. I'm a faculty in electrical and computer engineering and the new Department of Sound Arts and Engineering. And today I want to talk a little bit about acoustic sensing, some new methods that have come up with for that. This idea of spatial filtering, essentially you have some receiver and you've got people all around it. You want to block out sound from some of those conversations and enhance sound coming from some other direction. So you're filtering things by where they are in space. There's all kinds of signal enhancement applications, including source localization, source tracking, and source separation that you can do with these. There's any number of advantages. So normally I teach acoustics at this point, so I got to still get that in. So the way these typically work is you have multiple microphones, and you use the time delays between these microphones to enhance signals coming from one direction and reduce the energy from signals coming from another. And so you usually wind up with some plot like this, where we have frequency on the horizontal axis and the directivity on the vertical axis. And what that essentially means is at low frequencies, these things tend to be omnidirectional. And then they work pretty well at some mid-level frequency, and then eventually at high frequency we get spatial aliasing. And so like the omnidirectional problem essentially means that I pick up sound the same level no matter what direction I'm looking at. Up at this spatial aliasing frequencies, then I pick up sound basically with the same loudness that I pick up sound at some other direction. So the omnidirectional problem essentially comes from having sources that are too close together, and so that the wavelengths all are very large relative to the separation. And then the spatial aliasing comes in when I don't have enough sources in between. It's a sampling issue. And so to solve that problem, I draw inspiration from our friend, the Ormia acracia. So fortunately, nature has solved like all these problems for us. It's awesome. And so this fly eats crickets. And so to find crickets, it has to localize the cricket chirp, which is about 4 kilohertz. But its head is only about 1 millimeter wide. So it shouldn't be able to localize those sources, but it can actually. And that's because its ears are actually connected together by a mechanical membrane. So it uses not only the time difference of arrival at the ears, but it also uses the resonant coupling between its ears to find the direction. And so we do the same thing, just ramped up with a lot more modes, by affixing sensors to panels that have resonant surfaces. And so we can do this acoustic beamforming by looking at mechanical resonances rather than time delays down at low frequencies. So we can solve this low frequency beamforming problem. And it works really well for reducing off-axis radiation. The speech enhancement is really good. I'm not going to play the audio because that never works. But the key thing here is also because the panel has a very predictable response, if I know the response at one location, I can infer the responses at other locations, and so I can actually create some virtual sensors on the surface and solve this high-frequency spatial aliasing problem. So I can employ one real sensor and a bunch of virtual sensors and push that spatial aliasing frequency up. So we can make a wideband acoustic beamformer with only one sensor, which is really cool. So if you're interested in acoustic sensing or have ideas on this, I'd love to talk to you after. I have a poster that's not related to this at all, but you can still talk to me about that during the poster session. Thanks.
Good morning, good afternoon, everyone. My name is Jennifer Sertle. I am the VP of Partnerships and Marketing at Circle Optics, and I thought I'd take this full circle moment to talk a little bit about the company before I talk about what the company does. The company was founded by Zach Niazi, who was a student of Professor Travers, which is amazing. We have, I'm employee number 14, we now have 20, and the last 6 hires have all been software to really signal that optics collaboration with software, and I imagine that our team will grow more in software than in optics. I'm joined here today from Anjali Jogaswar, who is a PhD from RIT Imaging, and I just this whole full circle moment, and then hopefully I kind of mess up with these things. And then the last full circle is with Dr. Ballantyne, who talked about imaging intelligence, and that's exactly what Circle Optics does. And the last thing I want to say is that when Zach was a student, he thought, well, if Google can put something on a hat and go travel all around the world and see things, why can't I just go and travel and have a camera on my head? You know, that idea. And he took a physics-first approach and really changed 200-year-old science in optics to say it is possible to solve the stitching problem. And he stitched the very first 360 camera that was stitched together with hardware. And the reason I wanted to take the time to say that is with you students out here is that just because things have been created doesn't mean you can't go back to fundamental physics and come up with a new solution. And then the last thing is that I'm going to talk about in a little bit. We've been getting funding from the Department of Defense. We also started out actually from funding with Luminate. I want to thank Luminate and Damon for all the work that they've done because we were in Luminate cohort number 2, and that really allowed Zach to hire his first 3 employees. We then went into Genius New York, which is a drone accelerator, and that's where they were able to get the next batch of employees, including myself. And so the reason I'm also talking about this is that please give yourself 9 years. We have been funded for the last 7 years. You know, the first 2 years was funded through accelerators. Then the last I'm not going to do math right now. But I'm just saying, so the first 2 years was an accelerator, then the next was government funding, and now we have our first customer. So give yourself time, participate, network, and don't get discouraged. It will take time, and it will pay off. Okay, now what do we do? So the world needs to see 360, and we imagine panoramic imaging being pervasive. That's really what we do. And so what we're working on right now is counter-UAS, which is allowing us to detect drones in both the sky between MEO and LEO, as well as some are on that we're beginning to put on Air Force bases. And so the world needs to see in 360, but the current technology creates distorted delays and dangerous pictures. And here's the image of the very first. We right now have 23 patents. The first patent that Zach had in 2017 is about here, that you can see the idea of with having things stitched together, if you do it in a way, you can actually get the whole image in real time, panoramic capture. Panoramic capture, I think, matters so much now because so much of the world is changing and the landscape is changing. And if we can get images of things as they are, I think we'll at least have a historical record of what was, in addition to being able to have real-time imaging. And the current camera that is actually our very first product that actually we have a customer for is a camera called Pegasus. And again, Pegasus can be on a pole. We imagine it being at airports to really help the landscape there. And it also can be on a drone. And we're just excited about it. And then the reason I wanted Anjali to come with me today is that her team of 6 actually does this. You can see, only vaguely can you see the lines between, which is where the hardware is. This imaging is just in its real time. And then the next part, see this, we can show you what it actually looks like. That's outside the Sibley building. We also work where NextCore is, that has a lot of accelerators, which is kind of fun. But you can see the difference. And our ongoing work right now is actually trying to get some, oh gosh, Anjali, help me out with that. What is that? Long wave. Yeah, you all know. I'm in marketing. And so then you can see it's actually, and this is actually great news for you because I'm writing the press release now, and it will be coming out on Tuesday, but Deep Night AI is our first customer, and they're using our camera to integrate their software. Our cameras are designed for being software agnostic, but we really have our first customer, which is exciting. And then the bottom line is, here's our QR code. We'd love you to be part of our story. And we say, and this is actually, it's taken me 5 years to come up with it. It's taken 5 years for us to come up with a clarity. It isn't the user that's using cameras, it's actually machines. And so when machines must capture everything, they capture with Circle Optics. Thank you.
Hi, everyone. My name is Kate Jordan. I am the Senior Business Development Specialist with UR Ventures, which is the University of Rochester's Technology Transfer Office. But I'm also serving as U of R's Innovation Concierge for the New York Smart Eye Corridor Tech Hub, which I'll talk about in just a second. But the reason why I'm speaking to you today is wearing that hat and to share a funding opportunity for regional semiconductor companies looking to partner with universities. Just a quick overview of the New York Smart Eye Corridor, which many of you may have heard of before. Stands for New York Semiconductor Manufacturing and Research Technology Innovation Corridor, a mouthful, I apologize, namely the Tech Hub. It's a federal and state-funded grant awarded in June 2024 with the goal to position upstate New York as a global leader in semiconductor manufacturing, workforce development, and innovation. It is co-convened by 3 EDOs and broken up into 3 different components to support manufacturing, workforce development, and innovation. And while there is funding available to support all 3 components, I do want to focus on innovation today, which we've named the Commercialization and Collaboration Center, or C3. That's where I sit as Innovation Concierge. And C3 really aims to connect businesses with the tools, talent, and technology needed to accelerate commercialization in the semiconductor space. And to do that, the grant has leveraged about $7 million in funds to create an innovation voucher program called New York Thrive. And this funding is available to eligible companies who want to partner with the universities to utilize their facilities, their resources, or even to support R&D type projects with their faculty. And the universities that are participating are University of Rochester, of course, RIT, University of Buffalo, Syracuse University, and Cornell. So who's eligible for this funding? So again, it is the company, a regional company located in upstate New York that applies for the funding. And these companies must be involved in semiconductor design, manufacturing, technology development, or related sectors. However, I will say for the faculty and even students in the group here, if you're working on any semiconductor-related technologies and are already working with a regional company or would like to work with a regional company, chances are it might be covered under Thrive, so I encourage you to reach out to me. The funding available is ranging from anywhere from $50,000 all the way up to $250,000 or more for larger projects. I will note that Tier 2 and Tier 3 funding do require a match requirement from the company. We are accepting in-kind contributions. And I won't go into this in too much detail, but this is just to say that if your technology touches semiconductors in any way, shape, or form, chances are you are eligible for the Thrive program. So again, I encourage you to talk to me and I can talk you through whether or not your technology would qualify. And if you're interested in learning more, I do want to say that there's one of me, an innovation concierge, at all the other universities as well. And while we're and I will say that as innovation concierge, my role is to serve as a liaison between companies who are interested in Thrive or the Tech Hub in general to assist with the application process, the review process, as well as the contracting process. But at the University of Rochester, we are promoting really two avenues for funding, and that is utilizing our UR Nano space, which includes a clean room space as well as a metrology space, and of course R&D type projects with our faculty members. And if you can't find what you're looking for at University of Rochester, part of my job is Innovation Concierge to help connect you to the other universities in the system that might be able to help serve your needs. And so if you want more information, I have a lot more available. I couldn't fit it in the 3-minute time period. Please feel free to shoot me an email, or I will be at the UR Ventures table in the exhibitor hall later today. Thank you.
Hi everyone, my name is David Levy. I'm the CTO of Mosaic Microsystems. What we do is we work on thin glass for microelectronics applications. If you look inside your phone, you'll see a printed circuit that has metal traces on it that signals go through. Those lines are probably about 100 microns or more wide. That's probably many times the thickness of a human hair. You'll also see silicon chip packages on there, and inside those silicon chip packages will be the incredibly dense silicon chips that are in there, but there will also be other pieces of silicon that act like little printed circuit boards that basically have very fine line width, things like 2 microns, like 1/10 the width of a human hair. That's called a silicon interposer. We work in glass, and we believe that glass can replace both of those items there. The reason being is that glass is very rigid, very smooth, and so you can do all of the processes on glass that you could do on silicon to make those very fine lines. At the same time, glass can be made in sheets. It can be made actually even roll to roll, so it can be very, very cost effective, so something more like the printed circuit. But glass does something that the other materials do. It does something better than both of those other materials, and that's its capability to handle high frequencies. And that's due basically to the fundamental nature of the chemistry of glass. So why do you want high frequency? I think many people know this. Obviously, frequency in your phone, for example, 4G to 5G to 6G, correlates to bandwidth. If you think about AI applications as an example, there you have very powerful silicon chips that you want to mount on a circuit that will have very fine wires and be able to handle very high frequencies. And so we feel that glass is very much the future for that. We feel other materials are, other companies also feel the same way, but Mosaic's focus is actually thin glass. So it may sound like a detail, but basically all of these types of substrates, they have electrical circuitry on one side and on the other side. And then they have these small holes that we call via that allow those two circuits to communicate with each other. Turns out that the thinner you make the glass, the smaller you can make the vias, the smaller you can make the vias, the more stuff you can cram on there. So we're basically into thin glass. The problem with thin glass, and you can see from the picture there, is that it's floppy, it can break easily. And so we've solved that problem with a temporary bonding approach we call ViaFirm that allows us to attach that thin glass to a thicker substrate, and then it can be processed just like a piece of silicon can. So it can leverage all of the existing infrastructure and all of the high yield processing that exists. And I'll just end with what our vision is right now we have customers. We do small amounts of volume. Those customers are very interested in glass, very interested in the future of glass. We want to go from where we are right now to actually a full-fledged glass foundry or fab where we can actually do volume production, have it be onshore, and also actually lead in some of the capabilities that glass offers in the future, such as combination with photonics. So thank you very much.
So I am Mark Wilson, and many know me in a technical role here in Rochester in helping entrepreneurs and medical device startups. But all along, I have loved art and do certain kinds of art. Rochester loves science, and Rochester loves art. So I'm here to offer an opportunity to merge those two things together. Here with me is Robin Ham. Robin has started a new boutique art gallery, trying to get creative, interesting artists to have a place to display and start some interesting conversations. Right now, Robin has a call out for science people technology people, most everybody here, that actually do some kind of art. So if you're in that realm and you would like to apply, whether you're a professional, semi-professional, or a hobbyist, you'd like to apply to put your art in that show, please see Robin. Also take a card that's going to be right here up in front, or see us later. Now, also, Sharon Locke is here. Sharon has spent her entire life as an artist making art. Sharon's currently displaying in Robin's gallery. Sharon's science is studying the creative process. How do artists create? And actually professionally coaches artists to try to understand their process so to help maximize what they're trying to do in their creative process. Sharon followed her own method for the display that's currently in Robin's gallery. So Sharon took the prompt entanglement and light and shadows and tried to say, well, what will the art will come out of that? So if you'd like to see Sharon's art, please stop by the gallery tonight from 4 to 6 p.m. Just stop by, or reach out to schedule a tour. The gallery is very flexible, but only open by appointment. If you'd like to apply, please apply. Thank you very much. And you have some cards to wave to show people.
Yeah, so I have some handouts here and some cards and things, so anyone that's interested or knows someone that may be interested, be happy to talk to them.
Thank you.
This is simple.
Okay, let's make sure I get this right. Okay, so I'm Chris McCarthy. I'm with Keller Williams. For those of you that don't know Keller Williams, we have a commercial division. And commercial real estate is really complex and it doesn't function like residential. So what I'm here to talk about is we need lots of collaboration because all of the things discussed today as commercial real estate people we are dealing with, whether it's infrastructure. Biggest thing I'm having right now is I need someone that can help RG&E speed up the timetables to figure out if people can build in Rochester, because my cousin works for RG&E, full disclosure. 6 to 8 months or 5 years to run studies to find out if we have the power isn't acceptable to any business. And for all of you that advise businesses, I'm sure you have that issue too. But in other news, we need help for site selection. We need help to understand how to ingest legacy note cards that have been scanned in for municipalities, for zoning. You don't believe me? There are note cards. There are note cards that are scanned in. We need help with environmental and infrastructure risks. Policies are constantly changing. Example, DEC last year changed the regulations. Now we have delays over a year for some developers on understanding the regulations and getting DEC policies interpreted. Finance, strategic management, that sort of goes without saying, but incentives, planning, underwriting these. Is Rochester the best place for this business? Is Buffalo better? Is Texas? Is Florida? We deal with this, 2,000 of us across the country. We just want truth and not snake oil. I am the tech trainer for KW nationally for commercial. I've had in this short time here 15 emails from the solution people. None of them are university backed. None of them have the reputation of this area to tell us the truth of what we're actually looking at. So, questions, concerns, find me after. Thank you so much, and thank you to Lisa for telling me it was at the art gallery, not at the department.
Good morning. My name is Derek Marksell. I'm the Chief Technology Officer for Synergy IT Solutions. I'm just here to talk to all the brilliant people here in the room. We've been in business for 55 years. based in Rochester. We are an employee-owned company. It's a big deal for us. The benefit of being an employee-owned company is majority of our staff have been with our company for many years, much higher statistically compared to other IT providers. And a big part of our come to market is that we allow you as the business owner or developer, innovator, whatever you're doing, to focus on what you need to focus on. And we keep track of your assets, we keep track of the security updates, we do all the different kinds of things that make you secure and keep you up and running. One of the big things that we focus on is helping you create value, and the circle in the middle there is the value, business value, performance value, and experience value, different kind of components for your business and your ultimate customers. One of the things that we also focus on are compliance. You're getting into, some people here are focusing on governmental kind of work with the Defense Department, and CMMC compliance is becoming a big deal. We are in that field, and we are helping clients navigate that journey to becoming CMMC compliant. On top of that, we're also doing modernization. When I talk to customers, and one of the things I talk to them, especially when they're existing businesses, is tell me what your business looks like if you were to start from scratch right now, and you're eliminating the technical debt and operational debt that you have, and just wiping the slate clean and restarting. That is generally how I start conversations with customers, trying to put their head into the space that helps them envision kind of where they need to go and what we can do to help them get there. Don't want to take a ton of time, but we will have a table in the space. And again, listening to people talk about the really cool things they're working on is inspiring. So I appreciate the opportunity. Thank you.
Hey, everybody. My name is Mike Murdoch, and I'm a faculty member in color science at RIT. I'm the director of the Bunsell Color Science Laboratory and also head of the Integrated Sciences Academy, which is color science and neuroscience and part of cognitive science. You might be thinking, what is color science? Which is fine. So I put this helpful little triangle diagram up there, which is often how we start this conversation. Color is something that exists in our visual system, the eyes and brain, and it has to do with light reflecting off of objects. That's the physics side of it, and then the brain part is kind of the psychology side of it. We're interested in all three of those endpoints of the triangle there, right? We're interested in the objects themselves, the pigments, the displays, whatever it is people are looking at. We're interested in lighting, LED systems, multi-primary systems, color rendition, efficacy. And we're interested in humans and all the interesting variation among people, both in their retinas, but also in their visual processing. The plot on the bottom right there is the clouds of lines you see there, just to give you an idea of the range of the kind of variability you see among people with normal color vision, not even counting color blindness. We are a graduate program, so we offer master's and PhD degrees in color science, the only place in the country where you can really study color as a degree topic. And our research is, in some cases fundamental, also applied. Sometimes it's best if it's both. And we've had federal and a lot of industrial funding over the years. Pictures of recent research topics that we've had in our labs. It's a lot of people looking at stuff and working with materials and displays. Personally, I've done a lot of research with augmented reality. So on the right, the bunny and the faces, a lot about the perception of transparency. When you start mixing graphics into the real world, how do people perceive and understand those combinations? Our lab has done a lot with cultural heritage imaging, meaning very accurate images of paintings and other cultural artifacts. A lot of study of material properties of gloss, perceived properties like gloss and texture and other things. A lot of computer graphics, a lot of imaging. Some of us have history here in the Kodak and other imaging industries, and a lot of cool stuff going on there. Want to point out that I'm from color science, but within RIT we also have imaging science and photographic sciences and motion picture sciences as partners. We all work together regularly. As a grad program, we bring in those undergrads into our program, and really adds a lot of depth to our very multidisciplinary program. And then also here in Rochester, I know some of you in the room, we do partner in several different ways with the University of Rochester. I'm always interested in more connections if we can make them. But Frameless Labs, which is kind of an AR, VR focused organization centered at RIT. Studio X is kind of something similar on the U of R side. And I am a member of the Center for Visual Science, which was mentioned earlier today. So appreciate your attention, and I'll be happy to talk to anybody about connections we might make in the future. Thanks.
Okay, well, thanks everybody. I'm Lisa Beladoff, and I am founder and CEO of Bell Collaborative, and also our nonprofit Optics for the Greater Good. So, yeah, a little bit about me, but I'm here, so we'll skip that. But really, collaborative is this room, isn't it? I mean, to think about how many people I've partnered with over the years of when I was kind of welcomed, but by the secret handshake to get into optics, photonics, imaging, and lasers. I know there's many of us that are trying to welcome people, but it is a tough to navigate system. Out of the ashes of 3 large companies came many small and medium. Those patent holders are still here in Rochester. The people are still here. In fact, we're over 40,000 more employed people here than when we were in the heyday. So who are we? We're a consultancy. We're a group of professionals, some PhDs, some marketers, some BD and connectors. And it's really just about truly connecting the people who should already know each other and be doing business like we are doing here today. And often that has to be kind of highly curated because you don't want to waste people's time. And everyone's busy and this kind of thing. So the concierge, I heard Kate mention it, it is that kind of service that is needed because what we do is a little bit different, okay? And so whether that's market intelligence, business development, maybe it's the program management, because even when you're doing marketing for these technical companies, you really still are presenting to an engineering audience. And so being able to get there quickly is what we like to do. So we can be an extension of your team. If there's some fractional support, a lot of the startups and people spinning out, that's one of the things we do really well is maybe you don't need that COO or CTO yet. We can help you either augment and do that. And again, I've got a little bench of people I've worked with. I call them the A-team from all the places I've ever worked. So my old ITAR compliance manager who was the glass buyer from Kodak for 30 years, she doesn't really want to retire, so why don't I, use her to train the next people? So that training part is going to be big too, of what we offer. The subject matter expertise that we have is pretty unique. So I brought together a crew of people where, especially the AR, VR, that head-mounted side, whether it's soldier systems, lasers, sensors, the polymers, the novel materials, this is what my team and I have spent our careers working on. And so, the why Rochester just is so clear, but I will say that when you really dig into the other clusters. I'm also on the board of the Optical Society of Southern California. That's a group of volunteers. And by the way, they almost beat us for that AIM Photonics, okay? Just a group of group of volunteers, been doing it since the 1950s, the same year as SPIE started, okay? They just went in a different direction. So we all do very different things and need each other. Globally, but in the United States too. So how do we get that ecosystem connectivity? Everybody's kind of talked about it here, and what a great group to bring together in one room, because I have collaborated with almost everyone who has been up here and has helped me in my career when I was working at the manufacturer, working at Lightworks, Coherent, 26, now Adelon, working at Rochester Precision Optics, working down in Syracuse at Cable Express and doing data center and fiber. Like, I didn't realize I was in optics then until I got in precision optics, and then now everything is optics, photonics, imaging, and lasers, in case you didn't know. But it really all does come back to it, doesn't it? Aren't we embedded in almost everything? You look at AI and people think software and fancy math. It's hardware, people, and it's light. And so we are the problem and the solution there, I think. So whether you're looking for market intelligence, whether you're looking for an ITAR-friendly solution that also could include Taiwan and and how do I get it tomorrow in Rochester? The answer is we're still building that. So back to what Keller Williams said and taking everybody in this room, we let a lot of our things go. Everybody's got a phone in here. We invented that technology at Kodak with the molded A-sphere. And now there's only 2 places in the United States that do it, and we can't do it to the precision that is being done in China regularly. So things got to change. We're doing it. Research has to happen. But that public-private, this is why, and the artists in the room, please, you have got me. We've got to talk because I created an industry band for just the same thing. How can you own a laser damage threshold testing company and be an awesome bass player? How can you have spent, Mike DeMarco, I've asked to be my executive director. He spent 25 years at QED. He's our drummer. We are we're creating a database of all the people who are in optics and photonics who play an instrument. Or like me, you're just a fan, and I'm the super promoter. I'm the agent, I'm the A&R. Come see us next week. We are playing at SPIE Defense and Security. I just want to take a minute to thank everyone who has supported me and the ideas that I had about the nonprofit side too. Bell Collaborative was born in my attic. I called it the Bells Network. Bells is my nickname, or my college volleyball nickname too, high school. And that became different once we started building a team. And so everyone who saw this vision that I had, that has now become Optics for the Greater Good. And we are trying to meet people in non-traditional spaces because we need more people, period. Not just that there's only probably 5 women in optics or that we could use some more diversity, but it's everybody. Everybody has people to hire. We just pulled off a really cool thing with APOMA, which is the American Precision Optics Manufacturers Association, a lot of members here in the room. Keene State College, also collaborating a bunch with MCC on their diamond turning program. And then our little jolly band of band and people trying to make things happen for workforce development. So those are the things we are working most about. And again, this ecosystem, I gotta tell you, all roads lead back through Rochester, okay? We ship our optics and these photonics and the packaging to California, and then they integrate it into the satellite, or then to Florida, and then it does something else. So we're all doing different things, and seeing that and understanding where those pathways are for collaboration, you've met a lot of the people in the room that can make that happen. And how do you use Luminate and all the other tools to get those startups to want to stay here? And to show them a good, this is how we do business, and it's a very welcoming community. So with that said, I think, is that my fellow Geneseo old alumni, Billy Manza? Or a different Bill Manza? So anyway, I'll leave you with that. Thanks.
Okay. Not sure if Billy was able to make it. I know that it was a chance that he couldn't, so Billy doesn't seem to be coming up. So we're going to move on to the next part of it, but before we get to that part, I want to thank everybody for participating. I think there's a lot of innovation here. There's a lot of opportunity here. And what I encourage you to do, that after we talk about our partner awards, we're going to go to lunch, and there's going to be a great opportunity to network with all these people that came up here and spoke. I am amazed by the amount of tech and research and companies that we have here in Rochester, and several of them talked about being COE partners and CEIS partners, and a lot of you talked about networking with each other and utilizing each other in different business practices. So there's a lot to chew on here, and I'm sure that you took down a little bit of notes, made some mental notes. I urge you during lunch to meet with some of these people and talk to them. about what the opportunities for partnership might be for you. So the next part of this is our two organizations, the Center for Excellence in Data Science and Artificial Intelligence and the Center for Emerging and Innovative Sciences, cannot do what we do alone. And we want to celebrate some partners that have made a significant impact for us. And so the first award, I'm going to ask Mujat Chetan to come up for. So, and then here. Sorry, I did not practice this part. So Buffalo Solar is a partner that has worked with us over the course of a couple years. And we are pleased to have two representatives in Alyssa and Eric here today, and I'd ask them to come up if they're hanging around. All right, thank you. One thing I want to say is I love my job, and one of the reasons I love my job is you never know where that connection is going to come from. And Buffalo Solar, I have panels in my backyard, and I remembered Tyler, their president, and had reached out to him when I started working here because I thought data science could help him. So Buffalo Solar has been a valued partner of the Center of Excellence in Data Science and Artificial Intelligence for the past several years. They participated 3 times in the summer internship program and engaging with the University of Rochester, providing high impact and real world data science projects. Through this collaboration, student interns supported integration of business systems, development of data-driven tools, and the generation of actionable insights, and contributed to significant company growth. These efforts directly supported the COE DSAIs and generated more than $1 million in new revenue, and led to the creation of 5 new positions, including a full-time data analyst role. So in addition, through their work, they're expanding access to clean and renewable energy solutions. Buffalo Solar contributes to a more sustainable energy future for New York State. This partnership exemplifies the power of applied data science and reflects the COE's commitment to connecting academic talent with industry to advance innovation, workforce development, and measurable impact. So thank you again, Buffalo Solar, for your partnership. All right, and next we would like Mark to come up and present the next award. So CEIS recipient for this partnership award is James McGrath. James McGrath, come on up. James McGrath is the William R. Keenan Jr. Professor of Biomedical Engineering and the Director of the Translational Center for Barrier Micropsychological Systems. Since 2001, Dr. McGrath has been on a biomedical engineering faculty at the University of Rochester and served the BME for over 10 years as the first director of its graduate program. Jim has led nanomembrane research group since 2007. NRG is comprised of students, engineers, science faculty, and entrepreneurs at UR Simpor Inc., RIT, and expanding a network of academic and industry collaborators from around the world. Jim has co-founded 3 different companies to advance the commercial development and application of nanomembranes, Simpor, Proverio, and Cybox. Did I say that right? Cybex, sorry. His familiarity with the industry has motivated him to prepare his students by emphasizing the fundamentals of problem solving until the key steps have become habit. Very sciencey, I love it. For over 20 years, Jim has been one of the leading principal investigators funded by CEIS. He has been awarded numerous CEIS grants for his work with Simpor and on ultra-thin silicone nanomembranes. His successive research contracts and his developing of relationships with another company, Bausch & Lomb, are testimony to the quality of his work and the economic impact it has generated. So thank you very much, Jim. And I would like to thank you all again for coming to this session. I am standing between you and lunch, so I don't want to take up too much time. But if anyone has any questions or wants to connect with the companies and can't get a hold of them today, please reach out to us. We will forward that contact information, most of it which is in your program. So thank you again. And I would also like to thank Margaret Urzetta and Kathy Adams for all their hard work on this. Mark and Mujat, my directors, for their work, and Paul Valentine, and our interns, doing an amazing job taking photos and making sure that everyone stayed on time. So thank you very much.